September 12, 2025. Astronomers spot something impossible. A colossal object streaking in from deep space. Its tail stretches 5 times the width of a full moon, dwarfing anything seen since Oumuamua. Within hours, a second visitor is confirmed. Both are racing toward the sun for a close pass mere weeks apart, yet they're arriving from opposite corners of the sky. The odds of this cosmic double entry are, according to experts, astronomical. The official story? Twin comets. But the evidence points to something deliberately engineered. A bigger mystery is now entering our solar system, with a mission that nobody can explain. Is this an interstellar accident, or the first move in a secret operation triggered by us? The answer starts right here. On September 12, 2025, the SOHO spacecraft's SWAN instrument caught something that stopped astronomers cold. A new object, bright and unmistakable, blazing through the solar system. Within hours, the first data poured in. A tail stretching nearly 2.5 degrees across the sky that's just about 5 times the width of a full moon. That kind of scale is unheard of for a newly discovered comet. Initial readings put it at magnitude 7.4, bright enough for small backyard telescopes and even some binoculars. The news spread like wildfire. Amateur astronomers scrambled to confirm what the satellites had picked up. In Australia, just 2 days after the alert, an observer captured a dramatic image of the object, a streak of light so long it threatened to spill out of the camera's frame. By September 13th, the International Astronomical Union had made it official, naming the object C2025R2 with the tag SWAN in recognition of the instrument that first spotted it. Within a single weekend, both professional and amateur communities were locked onto this thing, trading images and brightness measurements across hemispheres. The sheer size and brightness set off a wave of speculation. Most comets discovered in the modern era are faint, often requiring powerful telescopes to see it all. SWAN, on the other hand, was visible to anyone who knew where to look, its tail slicing through the constellation Virgo and growing brighter as it drew closer to the sun. The initial reaction wasn't just excitement, it was disbelief. This wasn't just another icy visitor from the outer reaches. The numbers didn't fit any recent precedent. As the reports piled up, one thing became clear. SWAN was physically dominating the inner solar system in a way that hadn't been seen since the days of Hale-Bopp, or even further back. The amateur community, often the first to spot changes in brightness or odd behavior, was already debating what could possibly drive a tail this long and this bright. For now, the object was simply too big, too vivid, and too fast to ignore. And as the world's telescopes tracked its path, the question shifted from what it was to why it had arrived now, and whether its timing was just the first part of a much stranger puzzle. C2025R2, now officially known as SWAN, isn't the only newcomer drawing attention this October. Just days before its discovery, another object, 3I Atlas, was already inbound, making its own approach from a completely different sector of the sky. SWAN's path traces back through Aquarius, while Atlas entered from the direction of Sagittarius. On a star map, these two arrival points are separated by more than a quarter of the celestial sphere. Yet both objects are set to reach their closest point to the Sun, their perihelion, within the same 10-day window. For SWAN, that moment comes around October 20th, at a solar distance of about 150 million kilometers. For Atlas, it's October 17th, just 3 days earlier, skimming past the Sun at roughly 203 million kilometers. That puts their closest approach points only about 50 million kilometers apart closer than Mars ever gets to Earth. This isn't just a matter of overlapping dates. The geometry is striking. Both objects are on steeply inclined orbits, with SWAN's path tilted more than 60 degrees off the plane of the planets, and Atlas nearly perpendicular to it. Their approach angles are so different that, by chance alone, the odds of both crossing the inner solar system at almost the same time and at such similar solar distances are vanishingly small. Astronomers who track long-period comets and interstellar objects are used to randomness arrivals scattered across the calendar, with perihelia spread out over months or even years. But here, the two brightest new objects of the decade are converging on the Sun in near synchrony, each from a different corner of the sky. The timing adds another layer. As both SWAN and Atlas sweep through their closest solar approach, Earth's telescopes are effectively blinded. From October 8th to 18th, the sun's glare blocks direct observation, creating a blackout window that covers the critical days when any unusual behavior would be most visible. That means the moment of closest proximity both to the sun and to each other happens just out of reach, with no way for ground-based observers to watch events unfold in real time. To get two such objects from such widely separated origins hitting perihelion within days of each other at nearly the same solar distance, all during a period when the sun itself shields them from view, defies all expectations of chance. In the language of orbital dynamics, this is a corridor, a narrow window in space and time that both objects occupy together. Whether it's a coincidence, a hidden link, or something engineered remains an open question, but the geometry alone is enough to make even the most skeptical astronomer pause. 3I Atlas first drew attention not for its brightness, but for the way it broke the rules. Early spectrographs from the ATLA Spec Lab group reported something that set off alarms: a body dominated by nickel, with virtually no iron in the mix. That runs counter to everything we know about comets, which almost always show iron-nickel blends in their vapor. The claim was so unexpected, some labs immediately called for the data to be rechecked, sparking a calibration controversy that spilled onto astronomy forums and triggered a wave of independent reviews. The debate only intensified with the next round of measurements. Instead of the classic water vapor signature, 3IATL ACE's coma pumped out carbon dioxide at rates 5 times higher than water. The CO2 line dominated every spectrum, while H2O barely registered. That's rare, but not unheard of. What couldn't be explained away so easily was the behavior of its tail. Observers tracking ATL ACE's motion noticed a pattern: 3 distinct accelerations, each spaced about 2 weeks apart, and each coinciding with a sharp change in tail color. The first pulse was logged on July 29th, the second on August 14th. The data showed a sudden jump in brightness, while the spectral signature shifted from reddish to nearly neutral, and then back again. These so-called delta V pulses weren't smooth like the gradual push from solar heating. They came on fast, then faded, as if the object had fired a thruster. Reviewers pushed back, pointing to the risk of instrument errors. But the Atlas Spec Lab team defended their findings, arguing that the timing and magnitude of the pulses matched up across independent observatories. The numbers just didn't behave like typical outgassing. What really set the rumor mill spinning was the energy estimate. If the observed accelerations were real, the implied power source inside Atlas would need to deliver something on the order of 10 gigawatts, about the output of 10 large nuclear plants. That's far beyond what any known comet can muster. The mainstream view still holds that natural processes can account for most of the data, but the gaps, especially the nickel-only spectrum and the stepwise accelerations, have kept the engineered object hypothesis alive. C2025R2, now simply called SWAN, stands in a league of its own. The numbers tell the story: a tail stretching 2.5 degrees, a brightness peak that rivals the best comets of the last century, and a core that, if the wildest estimates are even close, could be pumping out 10,000 gigawatts of energy. That's more raw output than the entire power grid of Earth, but it isn't just the scale that has people talking. It's the claims coming from the fringes of the astronomical community, claims that SWAN is armored, shielded, and powered in ways that stretch the limits of current physics. The first whispers started with the reflectance data. Standard comet nuclei scatter sunlight in a predictable way, but SWAN's core reflects light with a sharp metallic signature. Some argue this matches not just nickel, but a nickel-cobalt blend materials chosen on Earth for their strength and resistance to corrosion. The term nickel-cobalt hull began circulating in chat rooms and late-night podcasts. Then came reports of an optical anomaly, a persistent, silvery halo around the nucleus, shifting in pattern and intensity. To some, it looked like a plasma envelope, a kind of electromagnetic shield that could deflect solar wind and cosmic debris. That's where the Fortress nickname comes from. Unlike 3IATLAS, which acts more like a drone, quick, agile, an oddly efficient SWAN presents as a tank, slow, steady, and seemingly invulnerable. The tail, already record-breaking in length, pulses with microthrusts that defy simple outgassing models. Analysis shows tiny rhythmic changes in tail direction, as if the object is making course corrections with precision bursts of plasma. Each pulse registers as a blip in the brightness curve, and the pattern repeats with a regularity that's hard to chalk up to random chance. The orbital numbers add another layer. Swan is on a path that will take it around the Sun once every 22,554 years. Imagine an object in space with an orbit so long, it stretches back to the last ice age. 22,554 years. A cycle so immense it predates human civilization as we know it. Now imagine that object, Comet Swan, arriving in our solar system at the exact same time as another mysterious object, Atlas, on a completely different, possibly interstellar, path. And here's the kicker. They both arrive during a brief window when the sun's glare blinds nearly all of Earth's most powerful telescopes. The odds of this happening by chance? Astronomically small. This convergence of bizarre events has fueled a growing suspicion that Comet Swan is no ordinary celestial wanderer. Its incredible brightness, hints of what could be advanced shielding, a potentially armored hull, and an energy output that dwarfs anything we've seen before, make it the most formidable object to enter our inner solar system in living memory. Is it a fortress? A probe? Or something we can't even comprehend? Swan is forcing scientists to tear up the rulebook and consider theories that, until now, belong squarely in the realm of science fiction. Every anomaly we've logged for both Swan and Atlas shifts the conversation. We're no longer just asking asterisk what asterisk they are, but asterisk what they might be doing asterisk. When two massive bodies, one on a 22,554-year return trip, the other on a one-way ticket from interstellar space arrive in near-perfect sync, the idea of coincidence just doesn't hold up. The timing, the geometry, the blackout window, it all points towards a mission. One theory, which sounds almost routine by cosmic standards, is a scheduled pit stop. In this scenario, our sun is the galaxy's equivalent of a service station. Both objects could be engineered to use its immense solar energy or magnetic fields to recharge, transfer data, or even run a systems check. We do this all the time with our own probes, using solar flybys for gravity assists and energy boosts. If these are advanced probes, our sun is the most logical place to top up their tanks and exchange information before heading back out into the void. But another theory is far less peaceful. This close approach could be an intervention. Perhaps one object is here to recover, or even neutralize, a malfunctioning unit. Or maybe we're witnessing a standoff between rival factions converging on a valuable resource. The estimated power levels are staggering. Atlas is clocked at around 10 gigawatts, but Swan registers a mind-blowing 10,000 gigawatts. That's not the energy of a passive, drifting comet. That's the kind of power reserve you need for active maneuvering for a mission with intent. We've seen hints of it too. Stepwise accelerations from Atlas and tiny microthrust pulses from Swan, suggesting a level of control that goes far beyond simple outgassing. Then there's the audit chain theory. Think about it. Oumuamua in 2017, then Atlas, and now Swan. Could this be an escalating series of responses to the century of radio signals we've been beaming out into space? Each new arrival might be a more complex probe, sent to check on the noisy neighbors, gather more data, or even prepare for a new level of contact. In every one of these scenarios, the sun isn't just a backdrop. It's the focal point. It's the power source, the meeting place, the beacon. The evidence doesn't give us a final answer, but it forces us to ask a brand new question. If this is a mission, what is the mission for? That 22,554-year orbit is more than just a number. It's a direct link to our planet's deep past. The last time Swan visited, glaciers covered much of the northern hemisphere. The world was a completely different place, and our ancestors were just beginning to shape the earliest chapters of civilization. That same era left its mark deep within the ice cores of Greenland and Antarctica. Layers of dust and chemical traces in the ice point to sudden dramatic events in the sky events that line up with periods, when bright long-period comets could have blazed across the heavens, leaving behind not just dust but myths and stories passed down through generations. At the heart of this idea is a place called Göbekli Tepe, a breathtaking archaeological site in southeastern Turkey, built over 11,000 years ago. Its massive stone pillars are covered in carvings of animals and strange symbols. Some researchers believe these aren't just art, but celestial maps, depicting the paths of objects in the sky, perhaps even comets. A few bold theorists argue that these carvings were meant to record cycles far longer than any human lifetime, possibly even marking the return of a cosmic visitor just like Swan. Now, mainstream science is understandably very cautious. Archaeologists and astronomers warn that these connections are speculative. It's easy to see patterns where there are none. The debate is intense, with critics rightly pointing out that there's no direct, concrete evidence tying these ancient monuments to specific astronomical events. Still, the timing is impossible to ignore. If Swan really is on this 22,554-year clock, its last pass through our neighborhood would have occurred just as the world was emerging from the Ice Age, a pivotal moment when human culture took its first great leaps building monuments and learning to track the stars. Is that just a coincidence, or is it something more? We don't know, but it adds a layer of mythic weight to an already extraordinary event. The story of Swan isn't just about orbital mechanics. It is about the tantalizing possibility that the sky's rarest visitors have been woven into the fabric of our own story since the very beginning. Then, things got even stranger. From October 8th to the 18th, a critical window, every major ground-based observatory on the planet faced a hard stop. The official reason? Solar conjunction downtime. But behind the scenes, something else was happening. Internal memos from US Space Command and the European Space Agency leaked, directing teams to suspend all radar and high-resolution imaging of both Swan and Atlas. Proposals for alternative ways to observe them were denied without explanation. Requests for raw data were quietly buried in red tape. A few brave insiders, speaking off the record, described explicit orders to avoid any public statements about either object until after they had passed the sun. The result was a forced global silence. At the exact moment when the two most unusual celestial visitors in decades were at their most interesting, the world's eyes were ordered shut. This left only a narrow band of independent astronomers and amateur networks to watch the skies. When the official channels went dark, the amateur networks lit up. Bill Gray, a legendary tracker known for his open-source orbit calculations, put out a call to arms across public forums and encrypted chats. He rallied a global web of backyard astronomers and small observatories with a simple message: keep your scopes on the sky, log every flicker, share the raw data before it disappears. Suddenly, a grassroots movement was born. The Ibero Tracker Collective in Spain and Portugal began pooling their sensor feeds. Leaks from private astronomy groups hinted at makeshift plans to use radio telescopes and even repurposed weather satellites to bypass the blackout. With government agencies silent and the big observatories on lockdown, this network of citizen scientists became the only line of defense against a total information vacuum. Anyone with a telescope, a radio dish, or access to tracking software could join the hunt. The blackout wasn't just a challenge. It was an invitation. It sent a clear message: if you want answers, you have to be part of the search now. The facts are undeniable. Two anomalous objects entered our solar system together, defying all statistical odds and raising questions that the authorities have refused to answer. When Swan and Atlas re-emerged from the sun's glare, the first signals didn't come from a government lab. They came from someone's backyard. The search continues, driven by people like you who refuse to accept the silence. Thank you for joining us on this incredible journey. If you want to keep exploring the universe's greatest mysteries, make sure to like this video, subscribe to the channel, and hit that notification bell so you don't miss what we uncover next.